Chapter 14, Sample Problem 14. A train approaches a station at a constant speed, sounding its whistle continuously. 3 students are discussing what an observer standing at a station would hear as the train is approaching. Anish says, the train is not accelerating or decelerating. I think the observer will hear a constant pitch that matches the pitch of the whistle. Brooke says, even if it isn't accelerating, the observer will hear a higher pitch than the whistle actually emits since the train is moving towards the observer. I do agree that the observer will hear a constant pitch. And Cruz says, I agree with Brooke that the observer will hear a higher pitch, but I think the observer will also hear the frequency increase constantly as the train gets closer and closer. So, let's walk through these things. This is clearly some sort of Doppler problem. This is a Doppler effect problem. And the Doppler effect says, if the range is decreasing, the observed pitch is higher than the emitted pitch. This is the Doppler effect. Here the range is decreasing. The train is getting, right? The train is approaching, so they're getting closer and closer. So we would agree with Brooke at least that the pitch will be higher because the train is moving towards the observer, so they will hear a higher pitch. Anish was right that the train is neither accelerating nor decelerating, but that's not enough to tell us that the pitch is the same. In fact, since the source is in motion, unless we had the same motion directly away from it, there has to be a Doppler effect, some sort of shift. But it's interesting to kind of talk about Brooke versus Cruz, because what's going on here is the piling up of wavelengths ahead, essentially. Your ear is triggered more often than you expect because the later sounds are emitted closer, so they get to you faster than they would if it had been still. But there's sort of an interesting thing. The people writing this almost certainly meant for us to just agree with Brooke and say, yay, Brooke and Cruz, you're a little off. But it comes down to where is the person standing. So if you imagine looking from above, here's our train emitting some sound, and then we have an observer, and I'm going to put Brooke here, but Cruz here. It turns out that if you're directly in front, then Brooke is correct. But if you're off to the side, then Cruz is correct, because the constant offset essentially changes the rate at which the extra wavelengths pile up, and therefore changes the frequency. This is the Doppler effect you've probably actually really heard, where something kind of rises as it goes past you, that kind of thing, as it runs away, getting right to your position. If you were standing directly in front, or if you imagine you're on the highway and you hear an ambulance behind you, you'll hear the siren does not rise in pitch as it approaches, but as it passes you to the side, it will rise in pitch and then drop tremendously and then rise in pitch again.